This is Algebra 2, Lesson 55 on page 237. The first part of this lesson is advanced abstract equations. We have already worked some abstract equations where we have to solve for one of the variables. Like it says, find m. Do you remember those? You had some in your homework? Okay, with the ones in this lesson are just a little harder. Look on page 238, the top of page 238. Look at example 1. All right, so what do you think is different about what you have already learned as compared to example 1? Yes, Nora? It equals what? It equals something, okay, but I think we still had something equaling something. What is it, Jake?
You have like addition in the numerator.
Correct. You have a binomial in the numerator. You see that? A plus B. So that when you multiply we have an equal sign. So what's the rule? Eliminate denominator. Let that just roll off your tongue until we get to trig proofs. It's the only exception to the rule. We do not eliminate denominators when we get to trig, proofs, and precalculus. Okay, so we have these binomials in the numerator. And so we have, when we're multiplying to eliminate the denominator, we have to distribute to both of those terms in the numerator. Okay, that's the only difference with this lesson and the previous lesson. So let's work example 1. A plus B over X. The only time I can eliminate a denominator is if this original expression has an equal sign, therefore making it an equation. All right, what am I going to multiply this by to eliminate the denominator? Michael?
Multiply everything by mx.
That's correct. Multiply everything by mx. Before I multiply, I simplify. So the x eliminates. Here's the difference. That m has to be distributed to both terms in that binomial. So we end up with am plus bm plus ymx equals kmx. And what are we solving for? We're solving for m. This one's going to eliminate. Yes, thank you. You caught me making a mistake. That's great. All right, yx. When I looked back, I said, that's not possible because every term has an m in it. The answer would be every value would work probably for m or none. Okay. Now what do I do? What's the next step? Yes.
Move all the terms with m to the other side.
So which way are you going to move m's? Left or right?
I just move them.
You just move them right. Okay, you can. All right, so we'll subtract the am, subtract the bm on both sides. To eliminate them, we're left with yx equals kmx minus am minus bm. What do we do next? Sarah?
I can't think of the word for it, but you separate the m from first.
Separate the m from, what is that called? Factoring. Factor out the m. What is factoring? What's another word for factoring? What am I doing to each one of these terms?
Divide.
I'm dividing by m. I'm dividing by m. So when I'm factoring, I'm actually dividing it into parts. Got it? All right. Now, what's the next step, Dylan? When I want to solve for m. Nathaniel?
You divide the term in the parentheses over yx.
Yes. I'm going to divide by what's not m on both sides, whatever's in the parentheses. Why can I do that? Why does this then eliminate on the right-hand side? Why does this eliminate?
Because it's 1.
Therese? Because it's multiplication. It's m times this entire term. And you can only simplify terms that are multiplied. All right, so here's the value of m. Not new, right? Feels almost the same. All right, let's work the second example. It is like this one as well. All right, now we're going to solve for x. And we begin with this. All right, what am I going to multiply everything by to begin with, Corinne? CX. Multiply everything by CX. Every term by CX. This middle one, I'll have to distribute it. How would this be different if this were minus? What would I then have to raise my attention to? Really focus on? Therese?
You have to subtract, or when you eliminate, you have to end up subtracting ECX.
So this negative would distribute to both of the terms, right? Okay, all right, before we multiply, we simplify, so we end up with x, MP. We have to distribute that CX. But because it's plus, both terms are not, the sign will not change for either one of those terms. But before we multiply, we're going to simplify. So it's plus DC plus EC equals DCX. Okay. Now what would you do, Evie?
You move all of the ones you're trying to solve to one side.
So what do you want to move and where?
Move all the ones with C to the right.
I believe we're solving for x. Did I write that down wrong? No, we're solving for x.
Oh, sorry. Then subtract X and P.
Yeah.
Sides.
Are there two ways to work this? Yeah, I could move the x and p this way, right? Or I could move this over here and these two terms over there. That seems laborious, but do people choose that way? Yes, they do. You do, some of you. All right, so we're left with DC plus EC equals DCX minus XMP. Again, we're going to factor the x out on the right-hand side. And we're left with DC minus MP. Then we divide by what's not x, which is DC minus MP. And that's the value of x. Okay, why is this important? Because of exactly what I'm teaching today in pre-calculus.
Does science square?
Yeah.
Yes.
You can square it, you can cube any. Because if I want to solve this for x, I have to do some isolation. And so I will remind my pre-calculus class today, okay guys, remember when. Okay, so now we're going to apply those same principles here, okay? So hopefully they will remember. All right, let's look at the third example. So the third example is not exactly like the first two. What is different about this third example? Yes, what is different, Mackenzie?
The additions in the denominator.
Yeah, now we have a binomial in the denominator. So that's going to make this thing so much more complex. So now what do I have to multiply every term by, Hannah?
Y times A plus B.
Yes. So I'm solving for A. So now I have to multiply by y times A plus B, y times A plus B, y times A plus B. And before I multiply, I'm going to simplify. All right, now I just have to distribute the A plus B to the mx. So I end up with A mx plus B mx plus dy. I'm going to take this py, it's already multiplied, and then I'm going to distribute the py to the A and to the B. So that we end up with pya plus pyb. Then we will factor out, well, we'll move every term with an A. Now we have to move both ways, don't we? We have to move some to the left, some to the right. I'm going to move my A's to the right and everything that's not A back to the left. So I'll subtract the AMX from both sides. And I will subtract the PYB from both sides. So that we're left with BMX plus DY minus PYB equals PYA minus AMX. We will factor out the A on the right-hand side. And then divide by what is not A on both sides to eliminate that term on the right. And we're left with A equals this value here. All right, the second part of this lesson is consecutive integers. Okay, we've worked with consecutive integers. But when we've solved for consecutive integers up until this point, we've only had one possible set of solutions. Now we're going to end up with a quadratic equation, and we're going to have to factor, and we're going to have two sets of possible solutions. All right, so when I'm thinking of consecutive integers, how do I write my consecutive integers? How do I write? Like, let's say I'm looking for 3 consecutive integers. How do I notate those? Do you remember, Nora?
Is it n plus 1, n plus 2?
Correct. All right, what about if I am looking for consecutive even integers? Therese.
Is it n plus 2, n plus 4?
What if I'm looking for consecutive odd integers? What is it, Nora?
N plus 2, n plus 4.
Correct. These are the exact same. Let's not forget that. All right, so let's look at our example. It says find 3 consecutive integers. We'll look here. Such that the product of the first and the third. So this is the first, second, third. We multiply the first and the third is 4 greater than 4 times the second. The second one is n plus 1. So we're always going to end up with an n squared. So distributing the n, we end up with n squared plus 2n equals 4n plus 4 plus 4. So what do you think I should do at this point? Michael? Combine like terms. Okay, so tell me specifically what you would do.
Add 4 and 4.
Okay, so begin by adding 4 and 4, which is 8. Okay, what would you do next, Michael?
Subtract. Maybe subtract. No, okay, never mind. Subtract 4n and then subtract 8, so you get n squared minus 2n minus 8 equals 0.
So you're really setting it equal to 0. All right, so you have n squared minus 2n minus 8 equals 0. Okay, can we factor this?
Yes.
Jake, what is it?
N minus 4 times n plus 2.
N minus 4, n plus 2. How'd you get that? Factors of
8.
negative 8.
Add together, you get
Add and you get negative 2. Got it? Yeah.
Would it, like, I know it's a more complicated way, but would it work if you did what we did to find, like, a perfect square?
Sure, it would. Yes, completing the square. Yes,
So that would work also?
it would work as well. Yes.
But that's not like a shortcut.
No,
Completing the square is a
No, no,
shortcut.
that-
This is a shortcut. Yes. All right, so what's the value of n? 4, 5, and 6, and
-2, -1, and 0.
you really have to think when they're negative. I really have to think when they're negative, right? Because you're going in a different direction. Well, the same direction, but